Two of the fundamental equations regarding entropy are the Boltzmann entropy equation and the Gibbs entropy equation. In both of these equations, we use the natural log function, and in this video, I want to provide some supplementary information on using logarithms. The first type of logarithm that people typically see is the base 10 logarithm, designated log, whereas the natural logarithm is typically denoted as ln. As I said, this is typical, but sometimes, often in older literature, you sometimes see log for the natural logarithm, and it can be somewhat confusing. While these two logarithms are the most common, you can have all different sorts of logarithms. The logarithm is simply a mathematical operation and is defined by the following equation. If you take the logarithm of some exponential expression and the base number of that exponential is the base of the logarithm you are taking, the logarithm will simply return the exponential factor. Taking the logarithm of a number that is not an exponential, or not the correct base, is rather easy. First, you convert the number you are taking into that form, and then whatever that exponential turns out to be is the value the logarithm will return. The natural log is the most common form of the logarithm used because its base, the natural number e, is useful in many applications of calculus and happens to show up all over the place. The most useful application of e that we will use is in derivatives. We're taking the derivative of e raised to some term is equal to the derivative of that term multiplied by the original function. One of the most interesting examples of this is taking the derivative with respect to x of e raised to the x, because the derivative of this function is the function itself. There are many useful mathematical relations that we can manipulate regarding the log function, and they are based on the properties of exponentials. The logarithm of 1 is equal to 0, and the logarithm of 0 does not exist. The logarithm of a product is equal to the sum of the individual logarithms. The logarithm of a quotient is equal to the difference of the individual logarithms. The logarithm of a value is equal to the negative logarithm of its inverse. The logarithm of an exponential is equal to the product of the exponential factor and the logarithm of the base. These are the main properties of logarithms that we are going to use, and remembering these properties should make solving problems using logarithms much easier. Thank you for watching this supplemental video detailing the properties of logarithms. If you enjoyed this video, please like and share this video as it helps considerably in increasing outreach. If you want to see more videos on chemistry and physics topics, please consider subscribing to the channel. I have linked my Patreon page in the description below, and if you would like to support educational content like this, please consider donating. Finally, please comment down below if there is something you feel like I could make more clear, or if there are other topics you would like me to cover. Thank you.